Good evening, children. 11th standard students of St. John's. We are continuing with our 5th chapter. Chapter name is Binomial Theorem and Sequences and Series. I already told you sequence and series is nothing but the base we know because you have studied that in your 10th standard also. Our topic is binomial theorem. We started with binomial theorem formula. And based on binomial theorem, we have completed 11 problems totally. Now we will go for the 12th sum. Problem number 12. Prove that c0 square plus c1 square plus c2 square plus etc. cn square is equal to 2n factorial by n factorial whole square. This is the result that we need to prove. So in this we have to understand that c0 means nc0. That is the meaning. C1 means NC1, that is combination. C2 means NC2, Cn means NCN. They have not given N. We have to understand that C0, the meaning is NC0. So NC0 square plus NC1 square plus NC2 square plus etc. NCN whole square. We have to prove that it is equal to 2n factorial by n factorial whole square. So in order to prove this result, we are starting with the formula that we know, 1 plus x whole power n. We have studied a formula for 1 plus x whole power n. What is the formula? Can you remember? The formula is this: nc0 plus nc1x plus nc2x square. It goes on like that, and it will end at ncn x power n. The same formula I have written here. Don't get confused. In place of nc0, we have just written c0 according to this notation. So actually formula starts with nc0. nc0 is written as c0 plus nc1x plus nc2x square plus nc3x cube plus etc. ncn x power n. So instead of writing nc0, we are simply writing c0. Instead of writing nc1, we are writing c1 like that. So actually this is the formula that we know. This is taken as first equation, and if you see the second line, the same thing I have written, but the order is changed here. Here it is 1 plus x, here it is x plus 1. I think you will accept this because in addition we can change the order, right? 1 plus x and x plus 1 both are same. So x plus 1 whole power n means the formula will change, right? What is the formula? Actually the formula is nc0. What is a plus b whole power n formula? If you just compare this with a plus b whole power n formula, you will understand. I will write the formula here. A plus b, for example, this is for your understanding. A plus b whole power n. What is the formula actually? nc0 a power n b power 0 plus nc1 a power n minus 1 b power 1. Plus it goes on like that, right? So this is the formula that we started the chapter with. With this formula only, we started this chapter, binomial theorem. Now if you apply this here, what is a? 1. What is b? X. So apply the formula nc0 a power n. A power n means 1 power n. 1 power n is 1. So b power 0, x power 0, that is also 1. So only nc0 will come. If you apply the second one, nc1, that is c1, a power n minus 1. 1 power n minus 1 means 1, so it will not come. B power 1, x power 1, x. So like that we have written everything. In the same way, you just imagine that, not imagine, you just compare this and this. What is a? X. What is b? 1. So if I substitute in this formula, nc0 is shortly written as c0. A power n, which means x power n, b power 0, 1 power 0, which is 1. So only x power n will come. Plus nc1 is shortly written as c1. A power n minus 1, x power n minus 1, b power 1, which means 1 power 1, and that is 1. We are not writing that. So this is nc1 a power n minus 1 plus nc2 a power n minus 2 plus etc. ncn. The last term will be ncn a power 0, which means x power 0 is 1. 1 power n is also equal to 1. So only cn will come. So no need to think in a different way. This is just the formula that we know. Even you can compare this for both these things. So 1 plus x whole power formula we know. X plus 1 whole power n means slight change will be there in this formula. Why slight change? Because in place of a, x will come. In place of b, 1 will come. Here in place of a, 1 comes, b, x comes. So that is the difference. This is taken as equation number 1 and this is taken as equation number 2. Multiplying these two, 1 into 2. Don't confuse. I'm not adding 1 and 2 or subtracting 1 and 2. Multiplying 1 and 2. So what happens? If I multiply these two, this will become 1 plus x whole power 2n because power will get added. N plus n, 2n. How to multiply the right hand side? If I multiply this and this, what will happen? C0 into C0, C0 square x power n plus C1 into C1, C1 square. If I take these two and multiply, I'll be getting x into x. This is also a base is x, here also base is x. Power is 1, power is n minus 1. So if you add the power, minus 1 plus 1 will get cancelled, x power n will come. Similarly, if I multiply these two, power 2 minus 2 will get cancelled, x power n will come. C2 into C2 becomes C2 square x power n plus etc. Cn, if I combine the last term, Cn into Cn, Cn square x power n. Actually, I should write plus etc. Can you guess how it is? Here it is plus etc. Why? Because C0, if is taken to this, another term will be we are getting. If I take C0 to this, many terms will come, but only I am just multiplying this and writing the answer here. Multiplying this and this, writing the answer. Multiplying this and this, writing the answer. Other terms and all I am not worried about because x power n will not come in other terms. Only x power n will come in these terms alone. That is why I am putting plus etc. Many terms will follow, but I don't want that because I am going to equate the coefficient of x power n on both sides. That is why I am collecting x power n terms alone. Hope you will understand. Again I repeat, first these two are the formulas that we have wrote, 1 and 2. Then multiplying these two, left hand side becomes power 2n. Here we will be having, when I take C0, if I multiply with each and every one, I will be getting many terms. Similarly C1x, if it is multiplied with each and every term, many terms will come. But we are not multiplying like that. We are just multiplying these two so that x power n comes. These two so that x power n comes. Only x power n terms alone I am multiplying and writing. Other terms I have written plus etc. dot dot dot. Why we are doing like that means, see the next line. Because of equating the coefficient of x power n on both sides. I am going to equate x power n coefficients on both sides. That is why I have collected all the x power n terms. Now see, I don't know what is x power n coefficient in the left hand side. For that we are calculating this. Just take this left hand side alone. Calculate the general term tr plus 1. You know very well this is nothing but formula for calculating general term. NCR a power n minus r b power r is the formula. Here in n place 2n is present, right? In place of n, 2n is present. So tr plus 1 will become, in place of n you put 2n cr. A means here it is 1. So 1 power n place 2n minus r. B means x power r. So in this formula we are substituting. What I want x power n term, coefficient of x power n. But x power r is present. I want n here. So put r is equal to n. In place of r, we are replacing n. So this line becomes tn plus 1 is equal to 2n c. Again in place of r, writing n. 1 power anything is 1. So leave this x power n. So what is the coefficient of x power n now? 2n cn. So to find coefficient of x power n of left hand side, we are doing this. So we are getting x power n. So this is the coefficient of x power n. So equating the coefficient of x power on both sides means for left hand side the coefficient is 2n cn is equal to, in right hand side what is the coefficient of x power n? C0 square plus c1 square plus c2 square plus etc. cn square. Right. So now I am writing all these things here. How to write 2ncn? Because we know the formula for NCR. I'll write the formula for NCR. NCR means how to write n factorial by r factorial into n minus r factorial. This is the formula for NCR. In the same way, 2ncn means how to write 2n factorial by n factorial, then subtracting these two, 2n minus n, again n factorial. So 2n factorial divided by n factorial into n factorial, the meaning is n factorial whole square. So that is the result that we wanted to prove. C0 square plus c1 square plus etc. cn square is equal to 2n factorial by n factorial whole square. Hope you will understand. We will pass on for the next heading. The next heading, this is again a theory class. The theory part you have to listen carefully and memorize the formulas. Write and practice all the formulas that we are learning in theory class, so that the problems you can easily understand. The heading is finite sequences. Finite sequence means you know very well, a sequence which have countable number of terms. Infinite sequence means it may go on. So we are going to see few progressions, arithmetic progression, out of which the first one is arithmetic progression, shortly written as AP. This you have studied in your 10th standard, just we are recollecting that. The general form of AP is given by A plus D, A plus 2D, A plus 3D, etc. So this is called general form of AP, where A is called first term, D is called as common difference. How to calculate common difference? You know, second term minus first term, D is equal to T2 minus T1. And also the general term of AP is given by A plus n minus 1 into D. So these are the things you know already in 10th standard. So this is the general form of AP. A means first term, D means common difference. The general term of AP or nth term of AP is given by A plus n minus 1 into D. Similarly, geometric progression means GP. The general form is AR, AR square, AR cube, it goes on. A is called first term, R is called common ratio. How to calculate R means T2 by T1. D means T2 minus T1. Common ratio means T2 by T1. The general term of GP is given by Tn is equal to A into R power n minus 1. How I am reading this? A into R power n minus 1. This is called nth term or general term of a GP. And another thing that we are studying in 11th standard is another new sequence, arithmetico-geometric progression. This is arithmetic progression, this is geometric progression. This is called arithmetico-geometric progression, shortly denoted as AGP. How it looks like? The general form is given by A plus D into R, A plus 2D into R square, comma, A plus 3D into R cube, like that it goes. So this is a new type of sequence that we learn. A first term, A plus D into R second term, A plus 2D into R square third term, like that it goes on. So this type of sequence is called what? Arithmetico-geometric progression. The general term of which is given by Tn is equal to A plus n minus 1 into D into R power n minus 1. I repeat, A plus n minus 1 into D into R power n minus 1 is called what? Nth term or general term of arithmetico-geometric progression. And the next one, harmonic progression. So for what are the things that we have seen? Arithmetic progression, geometric progression, arithmetico-geometric progression, and the fourth one is harmonic progression, HP. The general form is 1 by A plus D, 1 by A plus 2D, 1 by A plus 3D, etc. Again, if you look carefully, you can easily understand. If you see the denominator, it looks like AP, A plus D, A plus 2. So it is nothing but reciprocal of AP, is called HP. Harmonic progression. What is the general form? 1 by A, comma, 1 by A plus D, comma, 1 by A plus 2D, comma, etc. Now another few things that we are going to learn is harmonic mean. First we will see arithmetic mean. If A, B, C, if these three terms are in AP, arithmetic progression, then we can write B as A plus C by 2, which is called arithmetic mean. This B is called arithmetic mean of A and C. I repeat, if A, B, C are in AP, arithmetic progression, then B can be written as A plus C by 2. This you have studied in your 10th standard also as a condition. 2B is equal to A plus C. That is a condition for AP. Similarly, if ABC are in GP, then this B can be written as root of AC. This is called geometric mean. If ABC are in HP, harmonic progression, then this B can be written as 2AC by A plus C. This is called harmonic mean. So this is called arithmetic mean, geometric mean, harmonic mean. So you should know the formulas. In note, we are having two things. One is the results. Arithmetic mean is always greater than or equal to geometric mean. And in turn, geometric mean is greater than or equal to harmonic mean. That is what the statement says. So which will be bigger? AM, the next GM, and the last is HM. So AM is greater than or equal to GM is greater than or equal to HM. This is always true. Always arithmetic mean will be the greater number. And the second note is arithmetic mean, geometric mean and harmonic mean are always, they will be in geometric progression. They three will always be in GP. This is the result. And we can even check by taking some examples also. AM, GM, HM, all the three will always be in geometric progression. They three will be in GP. Which will be greater? AM will be greater than all the three. So with this concepts, we will go into the problems. But what you have to do is, you should first memorize all the formulas given in the theory part, write and practice. After thoroughing all the formulas, you should go for the problems. Now we will go into problem number 13. Question number 13. Write the first 6 terms of the sequences whose nth terms are, I think the question is very clear, we need to find the first 6 terms. Nth term is given. So 2 subdivisions are given. First subdivision is this and second subdivision is this. First we will take the first subdivision whose nth terms are. So this is nothing but nth term. So we are giving the name as AN. AN means nth term. That is the meaning we have to take. So AN is given n plus 1, n plus 2, n plus 3, n plus 4. It is very simple. Since we need to find first 6 terms, first find out the first term by putting n is equal to 1. So everywhere you put n is equal to 1 and simplify. A2 means put 2 in place of n, find out the value. Put 3 in place of n, find out the value. Put 4, 5, 6. So easily you can find all the 6 terms by replacing suitable numbers in this nth term. Same way, second subdivision, an is equal to minus 1 power n by n. So this is taken, since this is nth term, it is given the symbol an. Minus 1 power n by n. How to find first term? A1. So replace n by 1, 1. So the answer is minus 1. A2 means in place of n put 2. So 2 comes. Minus 1 power 2 is 1. So 1 by 2. A3 like this. Minus 1 power 3 is minus 1 by 3. So like that you have to calculate 6 terms. I think this is very simple problem. We will go for the next sum. Question number 14. It is also like the same problem like the previous one. Write the first 6 terms of the sequences whose nth term is given by. Again the same model sum, but slightly in a different way they have given. They have given an. An is equal to, it is given split it like two things, n plus 1 if n is odd, n if n is even. So if n is even number, we should use this formula. If n is odd, use this formula. That is the meaning. And second subdivision, an is n if n is 1, 2 or 3, and they have given a formula if n is greater than 3. So two subdivisions are there. We will take first subdivision now. This is the question. We will try to find out first term, a1. What is one even number or odd number? Clearly 1 is an odd number. So odd means I have to take this formula. In this formula, put n is equal to 1. 1 plus 1 is 2. So first term is 2. a2. 2 is even number. So I have to use the second formula. So in place of n you put 2. So 2 comes. a3. Odd number. So 3 plus 1, 4. a4. Fourth term. Even. n is even here. So use this formula. In place of n put 4. a5. 5 is an odd number. So 5 plus 1, 6. a6. 6 is an even number. Use this formula 6. So we have found all the 6 terms. First 6 terms we found out. Now we will take the second subdivision. n if n is 1, 2 or 3. So a1. First I am finding out the first term. If n is 1, I should use this formula. So a1 is 1. If n is 2 also, then I have to use this formula. So a2 is equal to, just put in place of n 2. So 2 is the answer. Even for 3, I should use this formula. So a3 is equal to, in place of n put 3. So answer is 3. So first term, second term, third term we found out using this. But if n is greater than 3, suppose 4 is greater than 3, I should use this formula. What I have to do, a4 is equal to, you put 4 here, 4 minus 1, 4 minus 2, 4 minus 3. So this becomes a3, this becomes a2, this becomes a1. But already we know a3, a2, a1. So 3 plus 2 plus 1, 6. a4 value we found out here. This is the fourth term. a5. 5 is greater than 3. So use this formula. 5 means this becomes 4, this becomes 3, this becomes 2. So a4 plus a3 plus a2. Add those 3 terms and write the answer. Similarly for a6, if you put 6 here, 5, 4, 2. So a5 plus a4 plus a3. Adding all this, we will get the sixth term. So again, this is simple, but we should know and understand the question. That is the important thing. Going to the next sum. Question number 15. Write the nth term of the following sequences. So far we found out first 6 terms. Now they are asking us to find the general term, nth term. Nth term is also called as general term. So write the nth term of the following sequences. 3 questions were given to us. First we will take the first sum. First sum is 2, 2, 4, 4, 6, 6, etc. So by seeing first term is 2, third term is 4, fifth term is 6. Try to analyze what I am telling. Listen carefully. First term means 2. Third term means 4. Fifth term, first term, third term, fifth term means 6. So what is the meaning? Fifth term means 6, 1 more than that. Third term means 4, 1 more than that. First term means 2, 1 more than that. So in odd places, the values are 1 more than that. So I am writing, if n is odd, the answer is n plus 1. Analyze it properly. First term 2, third term 4, fifth term 6. What will be the seventh term? 8. So 1 more than that. So that is why I am writing, if n is odd, then the value is 1 more than that, n plus 1. And go for the even places now. Second term is 2. Fourth term is 4. Sixth term is 6. So what I have to write? If n is even, the same will come. N is second term means 2. Fourth term means 4. Sixth term means 6. So n, if n is even. I hope you will understand that. Go for the second subdivision. This is the second subdivision, writing the question here. Now since it is in fraction, now I am going to look at the question like this. That is 1, if I see the numerator, it becomes 1, 2, 3, first term numerator 1, second term numerator 2, third term numerator 3, fourth term means numerator 4, So what I can think is first term 1, second term 2, third term 3 means I can just put n for numerator. For denominator, first term means 2, second term means 3, third term means 4, so 3 plus 1, fourth term means 4 plus 1, first term means 1 plus 1, second term means 2 plus 1, like that. So by thinking like that, I'm just writing the answer directly. The nth term is given by an is equal to numerator. How to form? First term means 1, second term means, so just write n. First term means 1 will come, second term means 2 will come. Denominator, first term means 2, second term means 3, so n plus 1. So the final answer is n by n plus 1. So by just thinking like that, we can directly write the answer. Okay. For the third subdivision, 6, 10, 4, 12, 2, 14, 0, it goes on like that. So here what we are doing is, we are analyzing the terms. A1, first term is 6, second term 10, third term 4, fourth term 12, fifth term, sixth term, seventh term, eighth term. So I am writing like this. Now if I see these numbers 6, 4, 2, 0, that is why I am writing it separately here. 6, 4, 2, 0. It looks like an AP. 6 minus 2 is 4, 4 minus 2 is 2, 2 minus 2 is 0. So it forms an AP. We know very well, for AP the general term is given by a plus n minus 1 into d. Substitute a means first term, 6 plus n minus 1 into d means difference. How to calculate the difference? T2 minus T1. 4 minus 6 minus 2. 2 minus 4 minus 2. So difference is minus 2. Bring this minus 2 inside the bracket so that it comes like this. 6 plus 2 is 8 minus 2n. Is nothing but for these terms. What are these terms? Odd terms. 1, 3, 5, 7. Similarly, if I analyze this, 10, 12, 14, 16, it goes like that. I am writing that here. 10, 12, 14, 16. That is also an AP because 2, 2, it gets increased, right? So same formula, Tn is equal to a plus a means 10 plus n minus 1 into difference is 12 minus 10, 2. Similarly, bring 2 inside, it comes like this. 10 minus 2 is 8 plus 2n. So now I've got what is the general term of this sequence. What is the general term? If n is odd number, this is the general term. If n is even, this is the general term, right? If n is odd number, this is the general term. If n is even means what? 2, 4, 6, even number means this is the general term, that is 8 plus 2n. So how to write the answer? We will see how to write the answer. Check whether this is right or not. So we can write the answer as an is equal to, if n is odd number, the answer is 8 minus 2n. If n is even number, the answer is 8 plus 2n. So this is the general term for the given sequence. Next sum, question number 16. The product of three increasing numbers in GP is 5832, which means product means multiplication. So multiplication of three numbers in GP is this. If we add 6 to the second number and 9 to the third number, what is the meaning? Add 6 to the second number, 9 to the third number, then the resulting numbers form an AP. Find the three numbers, that is the question. So in 10th standard also you know very well how to take three numbers in GP. We will usually take the three numbers in GP in this form, right? A by R, A R. Suppose if it is AP, we will take A minus D, A plus D. So always remember, three numbers in GP means we have to take like this: A by R, A R. What is given? Product. If I multiply these three numbers, the answer is given to us. So what I am going to do, multiplying all the three, A by R, A equal to this. R will get cancelled. A into A cube. This. If you calculate 5832 can be written as 18 power 3. So power 3, if I left out, A is 18. So I found out the value of A. Now I am seeing the next clue that was given to us. If we add 6 to the second number, what is second number here? A. and add 9 to the third number. This is third number. We should add 9. So what I am doing, A by R, second number is added with 6, third number is added with 9. If we do like that, the resulting numbers form an AP. So this forms an AP. What is the AP condition? 2b is equal to a plus c, right or not? B is equal to a plus c by 2, or 2b is equal to a plus c. So this is A, this is B, this is C. We know that these three are in AP, so I can use this condition. So 2 into B means this term equal to A plus this is C. So C means AR plus 9. Yes or no? Now what is A value? 18. So if I put 18 here, what happens? 24. 18 plus 6, 24. This becomes 18. This becomes 18, right? So I am going to substitute like that. So this becomes 24. And in place of A, 18. In place of A, 18, right? So 2 into 24. From these 3, take 9 as common. So you will get this. Cancel in 3 tables. 3 3s are 9. 24 means 8 times. So 2 into 8, 16. This 3 comes to the other side, becomes division. 16 by 3 is equal to, take LCM here. 2, LCM is R, right? So R, here 2 will come as it is. R will go here, 2R square, R will go here, this becomes R. Cross multiply again, 16 into R, 16R. 3 goes to this side, 6, 6R square, 3R. Arranging, 6R square, 16R comes to this side, minus 13R plus 6 equal to 0. Factorizing, 6 6R, 36. How to split? Minus 9 into minus 4 becomes plus 36. If I simplify, minus 13. Since 6 is present, we should divide both the numbers by 6. Cancel this. 3 by 2, here 2 by 3. So how to write? Denominator 2R minus 3. This is 3R minus 2 equal to 0. From this we can get two values of R. R is equal to 3 by 2. From this, R is equal to 2 by 3. Since we are getting two values, case 1, case 2. A value we know already, 18. Now R is equal to 3 by 2. The three numbers are what we have taken, A by R. So 18 by 3 by 2. A, 18. A, R. If I cancel 3 and 18, what happens? 6 will come. 2 goes up. 6 into 2 is 12. 18. Cancel 2 and 18, 9. 9 3s are 27. So these are the three numbers. In case 2, A is 18. R is 2 by 3. So the three numbers are A by R, A, AR. If I cancel 2 and 18, 9 comes. 9 into 3, 27. 18. 3, 6 times. 6 into 2, 12. So in both the cases, we found out the answer. Complete your classwork properly. We'll stop up to this and start revising all the chapters. So when a test is announced, you should be able to write in a decent way, right? Thank you, children.